Hi, everyone. My name is Eitan Bremler, Senior Product Manager here at Defender for Cloud. With me is Fernanda Vela, our Product Manager as well. We both are part of the Defender for Cloud product group, specifically Defender for Storage. And today we want to talk to you about how to use Defender for Cloud with it as a storage security solution. We'll start with going over the trends, the needs, what are the needs for storage security, talk about Defender for Cloud as a whole, and then we'll dive into specifically Defender for Storage, how it offers storage security. And then we'll switch over. Fernanda will do a demo and we'll wrap up. So I'll just turn off my camera so everything goes smooth and we'll dive straight into it. So before we start talking what is Defender for Storage and what is storage security, we need to understand what are the top risks you as our customers see today within storages. And this is from research we did and talks we had with customers, different roles, system admins, CISOs, application owners, workload owners, SOC teams. And what we're seeing is that there's two sets of challenges, operational challenges and threat challenges. On the operational challenges, we're talking about identifying hidden sensitive data, right? Storages are used today for storing sensitive and non-sensitive data. The most concern is how do I map out all my sensitive data for compliance, for regulations, for our own knowledge, right? Also sensitive data impacts the risk of our storage accounts. We want to protect maybe more, invest more in protecting storage accounts containing sensitive data. So we see 70% of organizations were concerned with recognizing sensitive data, especially around audits. On top of this, we have compliance, right? Compliance, different compliances have demands and requirements on storage security. For example, GDPR or HIPAA or DORA all mandate different regulations and different securities and policies on storage accounts, as well as the cost of ownership of managing storage security, right? The more storages you have, the more complex it becomes to secure them. And this is another challenge we're seeing on at customers, at organizations. On the threat landscape, we're seeing, again, three main challenges. The first one is malware upload. Almost half of organizations are concerned today with protecting against malware, either malware uploaded from the outside, from customers, or malware created inside or by mistake uploaded from an employee into a storage account. There's also a concern of data exfiltration. So not only the ingesting data, but also stealing data, right? So organizations are really concerned with stealing data to the amount that we're seeing that average breach costs could reach almost $5 million, especially for sensitive data being stolen, and data corruption, right? Also think about using storages for AI applications, for RAG, for baselining. If I corrupt that application data, the data stored in the storage account, I essentially affect the learning of the application. This is becoming a very big concern. Now, if we map out the need for storage security from a use case perspective, we're seeing two main use cases today at our customers. The top use case is what we call the enterprise storage use case, where storages are used to secure and to store company data. This could be employee data. This could be financial information. It also could be, like we said, data used for AI applications, right? So data here in your Azure storages could be used for baselining, for RAG, for AI application. It's important to make sure that data is not corrupted, is not stolen, does not necessarily contain sensitive data, because you don't want an application to create baselining over on top of sensitive data. This data here is usually more of a trusted area. So the storages here are trusted, the users are trusted. Still, we need to make sure the data here is scanned and is secure. The second use case, what we call the clearinghouse use case, essentially more of a zero trust approach, where the organization gets data from the outside. Think about HMOs, financial organizations, CPAs, medical organizations, or vendors getting data from other partners, data coming out from the outside, uploaded either through an API or through some web portal, hitting our storage account, and now an application ingests that data. This is because this is a zero trust environment. We don't trust the data coming in. We need to make sure applications only ingest clean and non-malicious data. So this is more of a pipeline-based approach of an application waiting for a file, ingesting it, then responding to the user. Pipelines, right? We need to maintain pipeline hygiene. So the idea is to scan the files when they hit or when they arrive into the organization. So if the top solution is enterprise data, we scan the data in the storages periodically to make sure everything is clean and for compliance. On the bottom part, again, we're more in scanning data when it comes in on upload into the organization. Our solution for storage security is Defender for Cloud, right? We'll dive deeper into the specific sub-plans that are used, but we're looking at Defender for Cloud as our solution for storage security. The idea is to offer a multi-layered approach to protecting your entire application stack, and specifically today we're talking about how do I protect the storage account being part of the entire application stack. And when we look at storage security, we're looking at protecting both the posture and the threat protection, right? Now it's a continuous job which Defender for Cloud offers, going from posture to threat and back. We understand posture might be managed by persona A and threat protection might be managed by persona B, but there is a connection. The system admin might manage the posture of your storage accounts, and the SOC might be tracking alerts coming from the storage accounts, but these two personas communicate. And the idea behind Defender for Cloud is to offer you this continuous workflow of ensuring the posture of your storage accounts is good, and we'll dive into what that means, but also looking at threat protection and what is actually occurring live in your storage accounts. All right. Okay. So specifically, when we look at storage security, again, we're looking start secure and stay secure. Start secure, security posture. The main requirement here is to find and prioritize and get recommendations on how to mitigate storage risk. Okay, and we'll see this, that with a one-click solution, we scan all your storage accounts and we tell you, Defender for Cloud tells you, okay, this is where you have risks in your storage accounts. This is where you have sensitive data in your storage accounts. These are your misconfigurations, and we offer you recommendations based on priorities to address these risks and these misconfigurations. The idea is to make sure that before you put data into your storage account, you're starting from a secure posture perspective, that your storage accounts are secure, they're not misconfigured, and you are calm in a sense, knowing that your storage estate is secure. We then go to the stay secure side, which is the threat protection side. Here is once you start putting data into your storages, what do we do? Here, the idea is to, one, detect and respond to storage threats. Okay, we know to look at all the events, control plane and data plane events, accessing your storage accounts and alerting to you if you have any risk to your files, if there's any access which is anomalous, if there's any exfiltration of data which is anomalous. And we also track malware by scanning malware in your storage account. So by combining threat protection and anomalous activity monitoring with malware scanning, we ensure your storages are secure in runtime. There's no malware, there's no live attack. So you can see that the story of start secure and stay secure ensures that throughout the life cycle of your storage account, you are covered. You're covered from the posture to begin with, and then in real time, in runtime, we track all the alerts and all the potential attacks on your storage accounts. And to achieve this start and stay secure, we recommend deploying 2 of Defender for Cloud's plans, the Defender CSPM plan for the posture side. That will give you sensitive data discovery, attack paths. You can see, and we'll see this in the demo, exactly which attack paths contain and include your storage account, right? Your storage account might be connected to a virtual machine, which is open to the internet, essentially sitting within a live attack, a potential attack path. You can get recommendations, see where are you in terms of regulatory compliance, all the risk, all the recommendations, all the risk factors, everything provided by Defender CSPM, all the posture management, the graph, the map. We'll see this in the demo. And Defender for Storage offers you the threat protection, the CDR side, if you will, whether it's activity monitoring, malware scanning, control on the resource level, right? Integration into Defender portal with the XDR, right? So Defender CSPM offers you the posture side. Defender for Storage offers you all the threat protection side, activity monitoring, anomalous behavior tracking, malware scanning. So let's start with the posture side, with how do we find and prioritize storage risks. The idea behind our Start Secure concept is to identify posture risks, right, using Defender CSPM, allowing you to automatically discover all of your estate, all your storage accounts, identify misconfigurations, identify which storage accounts are open to the internet, which have public access, which have anonymous access, over permissive access, sensitive data, and remediate it through the recommendations we offer. We offer recommendations per storage account, again, prioritized according to the risk factor. And all of these recommendations are tied to your secure score, to your regulation score. The idea is that once you fix your recommendations, your risk is lower and you are more compliant. So what you can see here, for example, is a potential attack path. You can see a storage account all the way on the right-hand side containing sensitive data, but it is sitting after a virtual machine which is with limited permission, which is vulnerable, maybe open to the internet. So though your storage account is not necessarily open to the internet in this scenario, it's connected up the pipe to something which is connected and open to the internet, essentially adding it into the attack path. So the idea behind our posture management, the Start Secure concept, is to show you this information, these insights, to show you that this storage account, which contains sensitive data, is a critical resource, is connected to elements open to the internet, and you need to address it. You need to address either the storage account or talk to the owner of the virtual machine that they will fix their virtual machine. And you can do this with one-click remediation. We give you the recommendation how to fix this attack path. We give you all the information, the recommendations, how to fix this. So that's on the posture side. Like we said, on the threat side, we need to be able to detect and respond to live and active storage threats. Now, this is done again by one click. The entire Defender for Storage plan is enabled with one click. You get activity monitoring, you get the sensitive data detection, and the malware scanning. Once that's active, the solution starts scanning your storage accounts, telling you where you have sensitive data, starts creating the baseline for activity in order to create the activity-based monitoring, and scans all uploaded files. On top of this, you can also do on-demand malware scanning. We'll see this in the demo, but in one click, you get protection, right? Again, anomalous monitoring, on-upload malware scanning, and sensitive data detection. Now, why is it important to scan for anomalous activity? Because if you think of a storage account today, it's not only control plane, it's also the data plane, right? Now, most people think about, okay, I'll look at the control plane. I'll see who's misconfiguring, who has maybe read-write permissions to my storage account. But that is usually for user-based access with an identity. However, today's storage accounts, and we know that, allow also access with keys or tokens, either permanent tokens or tokens with a lifetime on them. And those users access your data plane directly. They read files, they upload files, they download files. It's important to track that part, if you will, of the iceberg under the waterline, because that's where attackers will come in. They will look online for compromised SaaS keys, look for compromised storage accounts with public access or anonymous access, and that's where they will come in. And you can see here that from statistics, almost 70% of traffic to Azure storage today is used by SaaS keys, not necessarily by Entra IDs. So it's important to look at both the control plane and data plane, and that's exactly what Defender for Storage does. So we allow, so we track a wide range of activities with Defender for Storage, whether it's access token leakage, credential theft, reconnaissance, right? We can see who's accessing your storage account, from which applications, from which geographies, and alert on anomalous access, malicious insiders with permissions, compromised third-party keys, lateral movement. All of that is tracked by Defender for Cloud to generate a wide range of alerts, whether it's unusual malware downloads, malware uploads, unusual data extraction, data exploration, access from Tor nodes, suspicious IP addresses, suspicious applications, right? And not only do we know to tell you access is done to data, we can also tell you access is done for sensitive data. So a lot of the alerts here have two variants. We can tell you there's access from an illegal IP or a malicious IP to a storage with regular data. And we can tell you the same thing for storage with sensitive data. So it's because we know to highlight where sensitive data resides, and that an alert for sensitive storage account with sensitive data, you might regard as higher priority from your perspective than the same alert for a storage account that does not contain sensitive data. So this is a wide range of alerts that we provide. Again, this is all based using our anomalous detection engine. We have a baseline and we tell you what is anomalous. And once an alert is detected, an alert is generated. As you can see here, this is, for example, a compromised SaaS key alert. You get all the information for the alert description, the alert description, the affected resource, a lot of information about within the alert, whether it's an AD user or not, what is the user agent, what was the operation that was done, what was the SaaS key that was done. We provide you all the information in the details of the alert for analysis. That will then go into our XDR module, where it can be further analyzed and compared to other alerts. The same thing, as we said, can also be done for a storage account containing sensitive data. So you can see here, this is a variant for a sensitive data alert. In this case, the access level of a sensitive storage account was changed. rather than a storage account with no sensitive data. This is containing confidential information. You can see here the sensitive file types that this storage account contains and what is the sensitive information type. So again, we know to correlate the sensitivity of the storage account with the alerts. And like I said, on top of the alerts, we also know to do malware scanning. So there's anomalous traffic monitoring, but there's also malware scanning. We know to scan today malware either on upload. So whenever a blob is uploaded into a storage account, we get a trigger and we can scan it. So it's an out-of-band scan. Or we can scan files and blobs on demand manually by the user. So there's a button or an API, and you can scan your storage account. This is if the on-upload is good for scanning files coming from the outside for potentially malicious files from the users. The on-demand scan is very good for baselining, for audits. You know you have an audit, you run the on-demand scan, you make sure your storage account is clean, you have a report which can be showed to a auditor. We know to scan files up to 50 gigabytes per file, again, blobs and files. And of course, you can remediate once a malicious blob is recognized, either with our built-in soft delete remediation, which is a feature of Defender for Storage, that once a malicious blob is recognized, it is automatically deleted. This is for Azure blobs only, not Azure files, as Azure files do not support soft delete. Or through integration, as we'll see in a second, you can create your own remediation pipelines for quarantining, for deleting. Our scanning agent is the same scanning agent used throughout Defender for Cloud, allowing you for both metamorphic and polymorphic malware detection. You can filter which blobs you want to scan according to prefix or suffix. So it's a very, very granular solution. We'll see this in the demo. And like I said, you can either use our own remediation, our built-in remediation capabilities, or you can integrate through our variety of output channels to create your own remediation, whether it's reading index tags or reading Azure event grids, or looking at the security alerts within Defender Portal or Defender for Cloud Portal or Azure Log Analytics. There's a variety of options for you if you want to do higher level integrations, pipelines, etc. So a bit of what we released over the last 6 months. So in June, we released the option to do optional index tags. So if our customers use blob index tags for storing scan results, we allowed now to do that. That was the default action. This is now optional. It's on by default. You can choose not to use optional the index tags. We support today malware scanning in Azure Gov as well. We have integration into advanced hunting, which is Defender Portal Advanced Hunting. All of our alerts are into advanced hunting, where you can do very advanced queries and correlations, and our built-in malware automated remediation, which is also released. Again, built-in abilities to soft delete malicious blobs when you detect them. So we talked a lot. I'll hand it over now to Fernanda to show us the demo. Over to you, Fernanda.
Okay, thank you so much, Eitan. So we will jump into the demo, and in here we're gonna touch on how does cloud security, data security looks like within CSPM, how malware scanning works, and we're also gonna show some of the latest updates that Eitan mentioned in the previous slide. So something that a lot of customers usually struggle a lot, and this is something that Eitan surfaced, is that usually they have several storage accounts in their environment, not only storage accounts, but also storage across their multi-cloud environment, which is S3 buckets, Google Cloud buckets. And it's very hard to understand where they have sensitive information stored so that then they can identify it, they can notify the owners, they can also see if there's any attack paths, potential attack paths, any security alerts, any conditions that they need to tackle so that then the risk of a breach gets reduced. So one way to do this is when you go into the Azure portal, there is this tab within the Microsoft Defender for Cloud section that is called Data and AI Security. Within here, for example, you can see all of your sensitive data discovery. So for example, I'm showing the top sensitive information tab categories that we have within our entire environment that I have. Another way is that as soon as you click here in view all resources with sensitive information types, it is going to bring you into Cloud Security Explorer. Again, these are features that are available for Defender CSPM. And so as soon as you click on that button and you see this auto-populated, you can click on search and it's going to show all of your storage accounts, but also your S3 buckets, your GCP storage buckets that have sensitive information types. For example, if I just go here into this specific storage account, I can see all of the sensitive information types that there are there. For example, I see there's some social security numbers, credit card numbers, international banking account numbers, confidential projects. These are some that I set up. For example, here I can see exactly the location where all of these files are. Now, sometimes customers don't have, or they have a segmented team that has certain access. So sometimes the operations team doesn't have access into the Azure portal, and maybe they have access into the security.microsoft.com portal. And so within there, we also integrate all of these insights. For example, if I just go into security.microsoft.com and go into my assets in cloud inventory and go into data, I can include here a risk factor that says contains sensitive data. And this is going to show all of the storage accounts, S3 buckets, Google Cloud buckets that have sensitive information types. If then I click in a specific one that I just have here loaded, I can see some of these files. For example, I have in financials, which is a container, I have all of these files. Specifically, it is showing me the exact files that I have stored in this container in my storage account. I have the information type, and I have the exact location where it is found. So like I said, this would help more efficiently security operations teams to analyze their massive cloud inventory for data assets that they have in their environment. Now with that, sometimes customers don't understand what is the context around all of those object storage that they have in their environment. Maybe they do know that they have sensitive information types, but what is the context of that asset? Is it connected to any particular users that have every single permission, or maybe to servers that can access that specific storage account, or maybe some APIs? So in here, what we have within Defender for Cloud is attack path analysis. And here I already filter a few of these. And so I'm going to click in one of these ones that have a risk level of critical. Here I have an internet exposed Azure virtual machine that has high severity vulnerabilities, and it allows a lateral movement to a critical storage account that has sensitive data. I can see the entire mapping right here, so it's visually understandable as of what would be the entry points, for example, for accessing this specific storage account. I see it's a critical asset because it has a crown here. When I click here in the light bulb, for example, it's going to load some general details. And if I click here on Insights, it's going to tell me the sensitive information types that are there. Again, it's the same information that we saw a while ago. I also loaded here another attack path because this shows up many times with a lot of customers. Sometimes they have internet exposed APIs because they have a web application. And these APIs allow a lateral movement to also critical storage accounts that have sensitive data, which is not only used for storing employee data or customer information, but it's actually used for an AI application. So this is used for AI grounding. So for example, I can see here all of these APIs, such as add pet, update pet, create user, get user by name. We can kind of like understand the theme here of the web application that we're talking about, which is like a pet store. If I go here, it's going to be the same look and feel. We're going to have the API management service. We're going to have the operation, which is add pet. We have here a virtual machine that can authenticate as a managed identity that has access into a storage account. So the issue here is that when we have these publicly exposed APIs, anyone can just go in there and access moving laterally to this specific storage account. Now, this is not only shown here within the Azure portal, but we can also see it in the security.microsoft.com portal. From here, for example, I have another object, which is AI SPM Demo 12. And here what I'm showing is a similar type of event about internet exposed APIs that allow lateral movement to a storage account that is has sensitive data used for AI grounding. It's going to be the exact same story. I'm just going to have here also the access of how this looks like. It's even including in here the MITRE ATT&CK tactics of what could potentially happen, such as the initial access for exploiting the public-facing application, the execution, credential access, and even the exfiltration, because we're involving here a cloud storage. So with here, this is how we can map together sensitive data and also the context around it so that we can prioritize remediation and reduce the risk of having a security breach. Now I'm going to jump into a different topic, which is malware scanning. This is a feature that is within Defender for storage. And from here, I already have here loaded an eager test file. So an eager test file is the one that is going to trigger any antivirus that you have within like your laptop or within this type of services. In here, for example, I can see that I run it on October 15, and the malware scanning scan result was malicious. So this is an eager test file again. Now, I don't only have the results right here in blob index tags, but I can also have results when I go and export these results into a log analytics workspace. For example, here I already ran this specific query where I'm creating the storage malware scanning results table, and I'm looking for the specific scan result that is called malicious. I'm going to summarize it by storage account name. So for example, here I have this specific storage account that we were showing before, and I have here all of the malicious files that are within that specific storage account. Those are a lot, right? We have over 61 malicious files in here. Now, this is just a way for customers that they want to have this centralized view of all of the malicious files that they have within their environment. But it's not only sending malicious files, we can also send other type. We can also see other type of results, such as no threats detected, things like that, which then here increases to 168. And so we can see all of the also other files that we have within our environment. But for the purpose of these, we're just talking about all of these malicious files that get uploaded into storage accounts. And another way to look at the results about whenever we find a malicious file is that we can do it via security alerts. Here I'm showing a security alert that is called malicious file was uploaded into a storage account. And here, for example, we have which was the detected malware, which was an egar test file. I have it here by the name egar.zip. It is in a blob container that is called staging. It's also telling me the specific URL and also the file hash. Here, I have here, like I said, the malware. And then something very good is that when you click here into show events, it's going to show you the entire path hint. For example, we can tell that this is a zip file, but how deep is the malicious file in? We can see here there is first compression, then we have here the second compression, and then we have here the malicious file, which is egar-simulatingmalware.txt. Now, what happens, for example, when I download? So I already detected that there was a malicious file uploaded into a storage account. And maybe I didn't define any ABAC or role-based access controls into here. And so maybe anyone who has access into my environment can download and distribute this malicious file. Well, if that happens, we're going to detect it and we're going to have it with a security alert that is called Malicious Blob was downloaded from a storage account. And if I click on view full details, it's telling me the exact story. So there was a malicious blob that was downloaded from the container staging from this specific storage account. It's going to tell me everything, again, about the malware that was there. It's going to tell me here when was the event happening, what was the IP address, what was the user agent, what type of authentication type happened, if it was authenticated, such as, oh, I had to input my credentials, or if I was just using a SASCII token. So we're going to have all of these supporting evidence. Now, something very cool that we have recently integrated now in the XDR portal is that we can map together the incident once the file was uploaded and also when the file was downloaded. We can reference it all right here. So when I jump here into the XDR portal, I can see within the specific storage account that I had, which was this one, we can see it here, right here. So I'm jumping into the XDR portal and I can see there's a multi-stage incident involving initial access and lateral movement that involves multiple users reported by multiple sources. So here is not only Defender for Cloud, but we have also other sources that are getting involved. We can see here that there was a malicious file that was uploaded into a storage account. We have here an automatic deletion that failed. And then we also have here that the malicious blob was downloaded. So we have here the entire story that correlates from the file being uploaded into the storage account until the file was downloaded. If we click here, we're going to see the entire story. And it's going to show a map that has it all. Hopefully it loads. I didn't have it loaded before. So here is showing me the entire alerts that were happening. So it's been detected by a lot of sources. So Sentinel and other Defender products that we have within our environment. For example, here we can see some failed login attempts to an Azure portal, suspicious sign-in, things like that happening. we have here when the malicious blob was downloaded. We have here the entire path about what was the entire situation, and we can start correlating if this incident could be mapped into the downloaded malware. Another cool thing that I'm going to show here is another incident. This one is for a storage account that we call Woodgrove Taxes. And this is a multi-stage incident on one endpoint. Here, we also have a malware that was uploaded into a blob container, and then how it was also automatically deleted, because like Eitan was mentioning, we have an automation feature that is malware automated deletion. And so we're going to see this entire incident here. When I click on it, for example, it's going to show me again the same attack story. So here we can see how we have two detection sources. First, we have a server that has an application that allows people to upload files into a storage account. So we can see here that there's this cloud application that is Woodgrove Server Linux. And here we can notice that there was an eCard test file malware that was detected, but agentlessly. This means that this was detected by Defender, not by Defender for storage. But here we can see it. So it was detected here.
Hi, Fernanda. Sorry to interrupt you. Do you mind zooming in a little bit?
Yes, sorry for that.
My apologies.
Sorry, thank you. Okay, so here we have it again. We have the detection that happened within the server. Then the malware was uploaded into a blob container. Then we had here the automatic deletion. Then we also have another malware that was uploaded into the same storage account. Then we see we still have the remediation enabled. And we also see that there's more files being uploaded into this specific server for tackling this storage account. So we can see how there's different sources of how the files can be uploaded right here into this storage account. For example, if I click here, if I click in here, I can also see which are the files. For example, here I can see that it was an ecard.txt, a card.txt that was uploaded. Then here I can also see all of the files that were uploaded, also a card.txt. So again, here we're analyzing and putting together this incident that has several alerts that are related to each other based on the resources, the IPs, all of these contexts that we have within our environment. Now, I also want to showcase in here all of the latest updates that we have released for the past since June of this year. So I'm going to jump into a different screen. And hopefully it's big enough. So right here, I'm in a different environment. And one of the latest developments that we did was that now you can have optional index tags. So here you can see store scan results as blob index tags. We released this feature because we had a lot of customers that they didn't want to have the index tags in their environment because of budgeting or other use cases that they had. So we provided this in June. So what happens, for example, when a file is uploaded and I don't have the blob index tag? Is the malware scanning still working? Like, how can I know? That's like a very common customer question that we tend to have. So here, I uploaded a file earlier today, and it is this eager zip file. I can see that I don't have any value in my index tag, right? But when I go into my security alerts, I can see that around that time, I actually detected that file. So removing the blob index tag didn't affect at all the behavior of our malware scanning engine. So here I'm going to have the same look and feel that we were showing before, such as the blob, which is an ecar.zip. It was uploaded into a container that is called upload. I can see here the malware type is an ecar test. I can see how many times it has been compressed until it's the file itself. At the same time, some customers, what they do is that they don't enable the blob index tags, but they enable the send scan results to log analytics. So from here, for example, when I go into log analytics workspace, I can run this query for the table storage malware scanning results, and I can select show me all of the storage accounts that had a scan results type of malicious. This is very important to understand that we are not querying any index tag. We are querying the metadata from the blob itself. So from here, I can see, for example, the operation name. It was a scan. The storage account. I can see the scan result that was malicious, and I can see here even more information about it. Now, sometimes customers, they don't want to interact with the Azure portal at all. And what they want to do is that they want to just use certain applications to pull all of this metadata. So they usually ask us, hey, how can I query all of this information? And one way to do it, and I have it here, is by just using the index tags API. So I have here two sticky notes, one that shows what would it look like when I don't have any index tag within my environment. And here I have it with what would happen if I do have index tags in my environment. Here, for example, we can see that the tags set is gonna be empty. Like I said, I'm querying here the index tags API, so I'm pulling from the index tags. And in here, for example, if I do have them, it's gonna show my tag set as malware scanning scan result as the first value, and then the second value as no threats found. So this is how it looks like when we do it. Now, also sometimes customers ask us about the latest update that we did. That is the soft delete malicious blobs. I'm going to enable it right here in my environment. It's going to take a few seconds until it is fully enabled so that I can showcase what happens as soon as I upload a malicious file. We saw my environment. In my environment, I don't have index tags, and so we're not going to see that. But this feature is still going to be working. This was successfully enabled, and so I'm going to go into my containers within this specific storage account. I'm going to go into upload, and then I'm going to upload a file. I have it just right here. Is this one? This is an ecar test file. I'm just going to minimize this. I'm going to upload it here. And I can see it right here. I haven't refreshed my screen. So I'm going to refresh it, and I can see that it's gone. If I go here and put show active and deleted blobs, it is going to show that this file was deleted. Within my settings, I have a retention day of 6 days, but this can be changed by the time, whatever configuration the user wants. But here then I can see that the file was actually deleted. Then, for example, I can go again into my Microsoft Defender for Cloud Security Alerts. Let me just refresh this, change the screen. And I can see that I have a security alert that says that a malicious file that was uploaded into a storage account was automatically deleted. I can click in here and I can see all of those full details. I can see again, it was a eager test file. I can see what was the name of the file. You saw it all. It was .zip. I can see again the malware. I can see also how it was compressed. All of these was detected and logged right here within my environment. Now, another cool thing that we released recently was the cloud storage aggregated log. So I'm going to change again screens so that I can show it. When you go here into the security.microsoft.com portal and go into investigation and response, and then under hunting, you click advanced hunting, you can see that we added a table under cloud infrastructure that is called Cloud Storage Aggregated Events. In here, we're populating from Defender for Storage a lot of information that we have from all of the storage accounts that you have protected. So for example, right here, I'm running a use case scenario that some of my customers tend to run. So we saw that there's more than 51 million across unhealthy storage accounts across 5 industries that have SAS key tokens enabled. And that's not a good practice. So we have here expected authentication type being SAS. And I'm here just getting the information for the past 7 days. And here I'm going to summarize all of the operations by storage account, the authentication type. I'm going to include here the operation name so that I can tell what is happening within my environment. And I'm just going to run it. When I run it, I can see here all of the storage accounts that are using SAS key tokens for authenticating into my storage accounts. And I can see, for example, in this one specifically, that there was a list for all the files that I had in that specific storage account. And this happened approximately 60 times. So this is kind of like unexpected in my environment because I'm pretty sure there shouldn't be this going on. And nonetheless, like using the SAS key token. So within here, this is just an example of how you can use some of these parameters that we have within this specific cloud storage aggregated events. And there's a lot of information about it. We have the documentation that I can paste in a bit about all of the parameters that we have and what is the description of them. We also have here some sample queries. The one that I used was based on this one to list unusual authentication methods that are used. And with that, I'm gonna open it here into our slideshow to ask you if you want to become a design partner with us. You can scan this QR code or you can go into the link that it is gonna be posted. And I think it has already been posted in the Q&A. And if you want to be a design partner, please just fill it up. It's just going to ask you one single question just for you to provide us with your contact details so that we can reach out to you. And with that, we have here how you can start engaging with our products, such as our documentation, the introduction to Defender for Storage, how to enable it, malware scanning. We're going to share all of these links in the chat. And without further ado, I would like to thank you all. And Eitan, if you have anything else that you want to share.
No, thank you, Fernanda, for the amazing demo. Thank you, everyone, for attending. We have another couple of minutes. If anyone has any questions, we can address, and if not, we can wrap it up.
Eitan, it looks like there is a question for the end. One of our questions that came in for either of you. Can Defender for Storage scan encrypted files by purview MIP labeled for malware and SITs?
Yeah, so today we cannot scan user encrypted files because we don't have the keys, right? So that scan will be marked, right? You will know it was not scanned if you use, for example, the index tags, because again, it's encrypted with keys. There was another question here. I see that which part of Defender for Storage has to be enabled to have this table in Defender XDR? Just enable Defender for Storage. So once you enable Defender for Storage, you automatically have that, all the information that Fernanda showed in the aggregated logs.
Thank you. Okay, thank you, Eitan and Fernanda, for being our guests today and for sharing the great information with our community. Also, thank you to the Q&A team who helped us with answering the questions and providing the resourceful information. To all the listeners still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and desire to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become a part of our security community. Together, we can make a global impact. So join us at aka.ms/security community. This is also where you'll be notified about upcoming webinars, events, and other announcements. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.